Welcome to Hot Topics Time. Today, I want to talk about the development of China's large aircraft. In my opinion, China's localization of large aircraft can not only change the global aviation industry dominated by Airbus and Boeing, but also promote the transformation and upgrading of China's manufacturing industry to a high-end and advanced direction. In a word, the large aircraft industry is very important to China's development. For today's video, I checked a lot of information, found a lot of interesting things, and wrote down the script word by word. I guess it won't let you down. Please be sure to watch the end. Today, let's talk about what is a large aircraft and its development status in China. Why is this a war that China absolutely cannot lose? Are there similarities between the rise of large aircraft and the rise of China's high-speed rail? Okay, let's get started. First, what is a big plane? Big aircraft is actually not a rigorous aviation term, but just a name we call for large aviation equipment. In my opinion, large aircraft represent two types: large military strategic transport aircraft and large civil aviation mainline passenger aircraft. One plays a pivotal role in future wars, and the other is the most advanced means of transportation in the contemporary era, with a trillion-dollar market behind it. Our understanding of a large aircraft will be much deeper if we take it apart. A large aircraft is mainly composed of 5 major systems, namely fuselage structure, fuselage materials, power system, electromechanical system, and avionics system. Before I learned about the large aircraft industry, my understanding of the complexity of large aircraft was so superficial. But after studying for a while, I was deeply shocked by the complexity of it. To give just one example, let everyone feel the complexity of the aviation industry. Take fuselage structure as an example. In this field, weight loss is one of the core issues. An ordinary airliner, if it can lose 300 kilograms, can bring a net profit of $10 million to the airline every year, and the service life of an airliner is 20 years. In order to reduce weight, Air India only recruits slender stewardesses. In order to reduce the weight of the plane, Japan's All Nippon Airways requires passengers to go to the toilet before boarding the plane. It has been calculated that each less bottle of Coke on a plane can save $1,000 a day. Although the takeoff weight of an airliner can be as high as more than 100 tons, aircraft designers all over the world believe in a slogan that is, struggle to reduce every gram of weight. A gram of weight is more precious than a gram of gold. The weight of an aircraft is mainly determined by two factors. One is the material of the fuselage, and the other is the design of the fuselage. In 2017, Boeing invested tens of millions of dollars in a small company located in California, USA, just because it has special technical advantages in the manufacture of aviation aluminum materials, which can help Boeing reduce the weight and cost of fuselage materials. On the road to the development of China's large aircraft, the fuselage structure is an unavoidable hurdle. However, weight reduction is only a problem in the manufacture of the fuselage structure, and the fuselage structure is only a link in the manufacture of large aircraft. In short, countless such complex issues are intertwined together to form a large aircraft. Therefore, the design and manufacture of large aircraft is not so much a national key project as it is an all-round spot check of the national industry. Because behind the large aircraft is the summary of countless disciplines such as material science, metallurgical science, engineering mechanics, aerodynamics, and thermodynamics. But such a complex manufacturing project means extremely high value. According to forecasts, from 2020 to 2039, more than 40,000 jetliners will be delivered worldwide, with a total value of more than $5.9 trillion. And if China cannot participate in this feast as soon as possible, then most of the $6 trillion market will be divided up by the European Airbus and the American Boeing. According to data, in 2020, a total of 825 civil aviation aircraft of various types were delivered worldwide, of which Airbus delivered 551, accounting for 66.8%, and Boeing delivered 154, accounting for 18.7%. Moreover, the large aircraft is not just a commercial issue of the aircraft company, it actually drives the entire national economy. According to the research of Boeing Company, every 1% increase in the sales of civil airliners can drive the growth of the national economy by 0.7%. International experience has shown that if you invest 10 yuan in an aviation project today, you can get 800 yuan in 10 years. If one job is created in today's aviation project, another 12 jobs will be created in 10 years. Today, the large aircraft industry has created one technology, and 15 new technologies will be born in the future. In general, large aircrafts not only drive the development manufacturers and airlines, but almost have the power to drive the entire national economic system. Besides, we haven't discussed the military use of large aircraft. For example, the body of the American E-3 Sentinel early warning aircraft is a Boeing 707, and the body of the P-8 Poseidon anti-submarine patrol aircraft is a Boeing 737. So, a big plane is definitely more than just a big plane. For many years, large aircraft have been exclusively owned by European and American powerhouses with advanced manufacturing industries. Canada's Bombardier is also very strong. But in the past few years, it was only one step away from joining the big aircraft club, and then it was strangled by Boeing and Airbus. It can be seen that even if technical factors are not considered, it is not easy to make achievements in the field of large aircraft. If China can independently design and manufacture its own large aircraft, it will change the structure of the global aviation industry, changing the AB structure dominated by Airbus and Boeing into an ABC structure in which Airbus, Boeing, and COMAC compete for hegemony. On a larger scale, China's breakthrough in the advanced manufacturing industry represented by the field of large aircraft is a major improvement in China's international status. In December 2022, the C919 was officially delivered to China Eastern Airlines, the first user. By the end of 2022, the C919 has received a total of 1,035 orders from 32 customers. Generally speaking, the current progress of China's large aircraft is good, and it is advancing steadily. But I have to say, although China domestically produced large aircraft are making steady progress, from the perspective of the supply chain, China's aviation industry still has many shortcomings that need to be filled. In fact, the development level of China's large aircraft can be roughly perceived from the development level of the 5 major systems of large aircraft. After watching the following content, you should come to such a conclusion: the localization rate of China's C919 large aircraft project is not that high, and most of the materials and parts need to be imported at present. What? Is this contrary to your long-standing cognition? Is this true? Okay, let's move on. 1. Body material. For high-speed civil aviation airliners, the body material is the foundation. Engineers around the world are pursuing new materials that are lighter and stronger. At present, the mainstream aviation materials commonly used in the world are mainly composite materials represented by aluminum alloy, steel, titanium alloy, and carbon fiber. Especially composite materials, as the performance of aircraft becomes stronger and stronger, it has been increasingly used in various types of aircraft. The fuselage weight of China's C919 is about 42.1 tons, and aluminum alloy accounts for 65%. Compared with the Boeing 737 and Airbus A320 of the same level, the C919 uses less aluminum alloy and more composite materials. This shows that the design concept of the C919 is quite advanced. But the problem is that although the design concept is advanced, the development of Chinese materials and metallurgy is lagged behind. The right to supply aviation aluminum materials has been firmly in the hands of European and American companies for a long time. No matter in terms of technology or market, there is a big gap between China and foreign countries. In short, China's domestic aviation aluminum is still unable to meet the needs of large civil aviation aircraft. Composite materials represented by carbon fiber are currently the mainstream aviation materials. Composite materials with low density, high strength, high temperature resistance and corrosion resistance can especially meet the needs of aircraft designers for weight reduction. China has invested heavily in the development of carbon fiber industry since 2010. Thanks to the efforts of Chinese researchers, China has now become the world's third largest producer of carbon fiber, second only to the United States and Japan. 2. Power system. The power system represented by aero engine is the weakest field in China. The current international aero engine market is still dominated by European and American companies. For a long time, the development focus of China aviation development has been in the military field, and the civilian engine market is basically blank. Therefore, China's civil aviation aircraft basically can only choose foreign imported engines. 3. Fuselage structure. The fuselage structure consisting of wings, fuselage, empennage, and landing gear is the strength of Chinese manufacturers, which can meet the needs of large civil aviation aircraft. In addition, the fuselage structure part accounts for 30% of the total value of the entire aircraft. If Chinese manufacturers win all the orders for the fuselage structure of the C919, it means that China occupies an important position in the value chain of large aircraft. According to the available information, the companies under the aviation industry group have undertaken most of the work on the fuselage structure of the C919 aircraft. In other words, China has basically achieved self-sufficiency in the design and manufacture of fuselage structures. 4. Electromechanical system. Aircraft electromechanical system is a relatively unpopular field. When it comes to large aircraft, most people think of the fuselage, engine, and avionics, and often ignore the electromechanical system. The so-called electromechanical system includes multiple functions such as the fuel system, braking system, and life-saving protection of the aircraft. In other words, except for the engine and avionics, the aircraft is in the category of electromechanical systems. Like other systems, due to the lack of large aircraft projects, Chinese electromechanical companies lack experience in this area. At present, the supply rights of electromechanical systems for global large aircraft are still in the hands of European and American manufacturers. Thanks to China's investment in the aviation industry in recent years, with a series of domestic aircrafts put into use, Chinese electromechanical companies have gradually begun to construct their own supporting systems. 5. Avionics system. The aircraft avionics system mainly includes communication, navigation, flight control, weather and management systems, mainly to ensure the safety of the aircraft and reduce the workload of the pilot. In terms of avionics systems, the performance of Chinese manufacturers is quite satisfactory. The cabin core control system and information system are the only two domestically developed subsystems in the C919 avionics system, breaking the monopoly of Western companies in this field. To sum up, China's large aircraft industry is still in the early stages of development. Although China already has a complete machine, the performance of the 5 major systems almost lags behind that of foreign manufacturers, and the localization rate is low. This situation may seem a little bad, but it is actually normal. In a nutshell, civil aviation airliners are commodities, and the manufacture of civil aviation large aircraft is a business, and business needs to be solved with business thinking. For the business of civil aviation aircraft, there are only two most important factors: one is safety and the other is economy. For safety, aircraft manufacturers will definitely choose the most mature and reliable products. For economy, aircraft manufacturers will definitely choose state-of-the-art materials and technologies. After all, the difficulty of civil aviation aircraft is much higher than that of military aircraft, and for China, the development of large aircraft is a very urgent task. If we look back at the development trend of the global advanced manufacturing industry in the past 20 years, a very interesting phenomenon is that in all major industrial categories, there are fewer and fewer major players, and the threshold is getting higher and higher. I once communicated with an executive of Xiaomi and asked why Xiaomi chose to build cars. He explained Lei Jun and other core executives of Xiaomi's judgment on the end of the auto market. In the future, there will be no more than 5 major global players in new energy vehicles. This experience obviously comes from the situation of the smartphone market. Before Huawei was sanctioned by the United States, there were only 5 companies in the global smartphone market: Apple, Samsung, Huawei, Xiaomi, and Oppo/Vivo. In the era of feature phones, the global mobile phone market once flourished, including Nokia in Finland, Motorola in the United States, Samsung and LG in South Korea, Sony, Panasonic and Sharp in Japan, Alcatel in France, Lenovo and Gionee in China, Siemens in Germany, were once all-powerful in the world. In the era of fuel vehicles, at least a dozen countries around the world, including Japan, the United States, Germany, the United Kingdom, and Italy, have strong automobile industries. These countries all have their own representative brands, adding up to dozens of mainstream car brands in the world. If Xiaomi's prediction is true, there will only be 5 new energy vehicles in the world. At present, the leading new energy vehicle brand in the world, Tesla in the United States, is far ahead and is likely to occupy a seat. China has BYD, NIO, Xiaopeng, Ideal, Xiaomi, etc. It is likely that at least 1 to 3 companies will enter the finals. It also means that in the end, the world's new energy vehicle industry may not exceed 3 countries that can continue to stay on the table. A large number of automobile powerhouses in the era of fuel vehicles are likely to decline. If we analyze the R&D investment distribution of world enterprises, we can conclude that for a long time in the future, there will only be 3 regions in the world, East Asia, North America, and Western Europe, that may form industrial belts for advanced manufacturing. Other regions such as South America and West Asia, Africa, are basically out. After the financial crisis in 2008, major countries in the world are issuing currency indiscriminately, but people around the world do not feel the obvious impact about inflation. Why? Because in the past 10 years, the production efficiency of industries represented by advanced manufacturing has increased significantly, offsetting the impact of inflation. For example, LCD TVs that cost more than 5,000 yuan more than 10 years ago have now dropped to less than 1,000 yuan, because the production efficiency of LCD panels has been greatly improved. In other words, without the drive of advanced manufacturing, under the pressure of inflation, the lives of ordinary people around the world will be very sad. In the civil large aircraft industry, only the United States and France have the ability to independently develop and manufacture large civil airliners with more than 100 seats and can sell them on a large scale normally. Although Russia, China, and Japan have begun to develop their own large passenger aircraft, there is still a huge gap compared with the United States and France in terms of core technology breakthroughs and actual market share. This reality leads me to a rather scary association. If China fails to conquer the big plane problem, will China also be kicked off the table in a few decades? All in all, the large aircraft project is about industrial economy and technological progress at a small scale, and it is enough to be linked to national fortune and international status at a large scale. Therefore, large aircraft is a war that China cannot lose. Although the performance of C919 in the 5 major systems is not so good, I am still very optimistic about the development of large aircraft in China. The reason is, on the big plane, I see many similarities with the high-speed rail. In fact, today's large aircraft are very similar to the early Chinese high-speed rail. They also lag behind foreign countries and rely on foreign core technologies. Even at that time, China lacked even the ability to design high-speed rail trains. However, China's high-speed rail can still make a beautiful turnaround within a few years. The secret behind this is China's high-speed rail thinking. The core of China's high-speed rail development thinking is to cultivate capabilities, which are more important than products. During the development of high-speed rail, China insisted on co-designing high-speed rail with Western vehicle manufacturers, thereby cultivating high-speed rail design capabilities and solving problems such as what should be considered, how to do it, and why to do this. In the subsequent manufacturing stage, China also arranged a series of links to ensure that foreign manufacturers can teach Chinese manufacturers to cultivate their manufacturing capabilities. This is the high-speed rail strategy, which is also reflected in China's large aircraft project. As the main manufacturer, COMAC is responsible for R&D and design, complete machine assembly, marketing, and after-sales service. And these links are precisely the places where the most profit is made in the entire value chain of the large aircraft industry. The fact that Chinese manufacturers can occupy these links proves that COMAC controls the dominance of the domestically produced large aircraft project, and also guarantees that C919 must be a Chinese brand. China started the high-speed rail project around 2000, and started large-scale operation in 2008. It officially established its position around 2018. This process took 18 years. The development cycle and difficulty of large aircraft are much longer than those of high-speed rail. Therefore, it may take longer for the domestic large aircraft project. How many years do you think it will take? Well, thanks for listening. If you have any suggestions, just leave them in the comments section. We'll come back as soon as possible and check them, and then we'll give feedback. See you next time.